So, all right, 6.4 unit circle and trig ratios of special angles. Okay. The unit circle means that your radius equals 1. Does that make sense? A unit. Okay. It's used to help you find the trig ratios for any of the quadrantal angles. That's the main goal of the unit circle, is to help you to find your quadrantals. Okay. So our quadrantals were 0, 90, 180, 270, and 360, right? Now in radians, again, 0, pi over 2, pi, 3 pi over 2, and 2 pi, right? Those are our quadrantal angles. There are angles that lie on our axis. Yes? With me? Okay. A unit circle. If I have a unit circle, that means that each point is 1 unit from the center, the origin. Agreed? So from here to here, I'm now here. I've went 1 unit to the right and 0 units up. Does that make sense? From here to here, I went no unit left or right and 1 unit up. From here to here, I went left 1 unit and 0 units up or down. From here to here, I went 0 units left or right and 1 unit down. Okay, so those are our first ordered pairs that we're learning. They're the ordered pairs of the quadrantal. Okay, key thing here is the ordered pairs represent the cosine and sine of that value. Okay, the reason being is because if I'm at a unit circle, remember our sine of an angle equals y over r, right? Cosine of an angle equals x over r. Tan of an angle equals y over x. If my radius is 1, then therefore the sine and cosine are just going to be whatever the x and the y values are. What are you doing? What the sine, cosine and sine values are. Does that make sense? Okay. So conclusion here is that our x comma y is going to be our cosine comma our sine. Okay. Sure. We can also use our reciprocal rules here, or recall our reciprocals. So what's the reciprocal of sine? What is it called? Yes. Cosecant, right? Cosecant theta, which equals r over y. Reciprocal of cosine is secant theta, which equals r over x. And the reciprocal of tangent is cotangent theta, which equals x over y. My x looks like a K, and I don't know why. I'll try to. Okay. So knowing this, knowing that r is 1, knowing that what my x and my y are, can I find the trig ratios, if asked, of any of my quadrantal angles? Why, yes, I can. So let's try together. So if you look right here, it says find 180 degrees. So we're finding the sine of 180 degrees. Well, sine we said is y over r, but we narrowed it down to being that your sine is going to be your what of that? Y. Your y. And what is the y value of 180? What is the y value? 0. If you forget that, it's y over r. And so again, y over r equals 0 over 1, which is just going to be what? 0. Okay. One thing I want y'all to remember is that it is okay for 0 to be in the numerator. That means it equals 0. Exactly. It's a no-go for 0 to be in the denominator. That means it's undefined. Okay. All right. So we put 0 on the blank? It should be 0 on the blank. All right. Cosine. So the cosine of 180. Cosine, we said cosine is our what value? Our x over r. In this case, it would be what? Negative 1 over 1, which is just negative 1. Okay.
The r value not matter because it's 1.
I mean, it matters, but it's because it's 1.
What's that on the right? Is that CSC?
Cosecant, yes. All right, cotangent of 270. How would you find cotangent? Cotangent, what's the relationship? X over Y. So if I go to 270, I end up with what? 0 over -1. So 0 over -1 equals 0 because it's okay in the numerator, right? All right, tan of 90. So tan of 90. So here's 90, 0, 1. Tan means Y over X. Well, that's going to give me 1 over 0. And 1 over 0 is what? Undefined. It's a no-go. So it's going to be undefined. Okay. Cosecant of pi over 2. Again, pi over 2 is another way of saying 90, right? So cosecant. Cosecant is what?
R over Y.
R over Y. So what's my R? 1. And what's my Y? 1. So it's just going to be 1.
So does R equal R?
All of the R's are 1. So
Okay.
if you read right here, what did it say in the paragraph? We boxed it. The unit circle means your R equals 1.
So is that like an always?
And always for your quadrantals. That's why these points will never change.
Do we need to
With
remember,
any, you will.
remember that?
Mhm.
Like, okay.
You're gonna be given a blank unit circle and you're gonna have to fill it in.
I want to.
Don't quit.
I don't want to really do it.
It's too late.
I know. All right, come on, next one.
All right. And then the last one we have secant 2 pi. So 2 pi, what is its ordered pair? 1, 0. And secant means what? R over X. We see that? Secant means R over X. Our R is 1. Our X is 1. So secant 2 pi equals 1. Okay. The quadrantal angles are the easiest to understand how the ordered pairs help you find your trig ratios. Okay. You're supposed to build that skill in 6.3 using your ordered pairs of any point, right? Now we're talking about points that specifically lie on the unit circle.
Is that okay?
Nothing's a K. If it looks like a K, it's probably an X.
Oh, that is okay. Yeah, that's okay.
That's good.
Wait,
Okay.
what? Okay.
Oh, there. I thought you were talking about like up here.
No, don't.
Yes, that's a K. That's a K. Yeah.
Oh,
I forgot about that guy.
oh my God.
All right. Okay, now we're going to move into our 45. So we're going to figure out the ordered pairs for our 45 and all the other ratios. Okay. So we're going to find the trig ratios for theta equals 45 degrees. Now we're going to set this up by remembering a right triangle. I like to draw it in the unit circle. You don't have to, but it helps me. So if I have a 45-degree triangle, that means that both angles are 45, right? Okay, if both angles are the same, that means the two sides are the same, right? Okay, so we let this ratio be 1 to 1. If both sides are 1, and we use 1 because it's just an easier number it can be a ratio of anything, 2 to 2, 3 to 3, but ultimately the ratio comes down to being 1 to 1, right? If one side changes, then the other is going to change. Does that make sense? So if 1 is 2, then the other has to be 2. Okay. Now, when you know two sides of a right triangle, how do you find the hypotenuse?
A squared plus B squared equals C squared.
A squared plus B squared equals C squared. Agreed? Well, what's going to happen here? We have 1 squared plus 1 squared. And what is that? 2. And so then we're left with, so it's going to be an irrational number, which is square root of 2. So now you have your X, you have your Y, and you have your R.
Does it matter which one is X, Y, and
Well, X goes horizontal, Y goes vertically, and R is always your
Well, that makes
hypotenuse. Okay. So now, do I have everything I need to find my sine, cosine, tangent, and everything? Yes, no, maybe so?
I think so.
Okay, so key thing to remember is that sine is going to be your Y over your r. The reciprocal is r over your y. Cosine is going to be your x over your r. Reciprocal is going to be r over your x. Tangent is going to be y over x, and the reciprocal is going to be x over y. So I'm going to give you a couple minutes to fill it in, check with your peers, and we'll keep going. If you need help, let me know. All right, so our goal here is to find these ratio, but most importantly is to figure out what is the ordered pair where this point would lie on the unit circle so that the radius would be 1. Okay, that's going to come by from knowing our sine and our cosine. So sine of 45 degrees, you should have gotten 1 over the square root of 2, right? Can we leave it like that? No, we have to rationalize, which means we multiply the numerator and the denominator by the square root of 2. And that's going to give us square root of 2 over 2. Got it? Okay. So here, the cosecant is a reciprocal, which is easy. So that's just going to be square root of 2. Cosine is the opposite of this. So cosine is going to be the square root of 2, but its reciprocal is going to be, I didn't mean to write that. Cosine is the same. Ignore us at opposite. That's for 30, 60, 90s. It's going to be the same, and it's going to be square root of 2 over 2, square root of 2. Do I have to redo the math if it's going to be the same? No. And then tangent. Tangent is wide. It's just going to be 1. 1 and 1, right? All right. So from here, we now know in order for this radius to be 1, the distance, this point has to be at square root of 2 over 2 and square root of 2 over 2. I didn't hit it, the note, okay? I left it alone. Whatever. All right. Trig ratios. So 30 degrees. Again, the right triangle rules are to help us figure out where things are located. So we're going to create our right triangle here. Does anyone remember the right triangle ratio for 30, 60, 90? Anyone? Nobody? Remember? What makes 30, 60, 90 special? It's okay. All right, so so we have 30 and we have 60, right? Across from 30 is going to always be your smallest side, okay? So when you're talking about ratio and comparing things, the smallest value that it can be is 1. So this is going to be 1, okay? The relationship between your smallest side and your hypotenuse of a 30, 60, 90 is 2. Your hypotenuse is double the length of your smallest side.
Oh,
That is relationship between.
I remember that.
Huh?
I do remember that.
We're setting up a ratio. It's just the smallest in the ratio. Yeah. So this would be 2. Okay. So like if I had a 30, 60, 90 and I knew my shortest side was 4, you would tell me my hypotenuse is what? 8, because that's the relationship between hypotenuse and short leg of a 30, 60, 90. Okay. Now, because I now established that relationship, how would I find the third leg?
C squared minus B squared equals A squared.
There we go. C squared minus B squared, right? That's going to be 4 minus 1, which is 3, but it has to be the square root of 3. Because you don't want C squared, you don't want A squared, you just want A. So now this is our X, this is our Y, this is our R. Can I find all my ratios now?
Yes.
All right, find your ratios. Okay, it's all right. Here we go. Sine of 30. What's the ratio for sine of 30, D? What's the ratio? What's the ratio? Y over R, right? What's your Y? What's your R? What's your R? So therefore, what is the sine of 30? It's 1/2. Woo, you did it. Okay. Okay, remember sine is Y over R. Cosine is X over R. And tan is Y over X. Okay. So let's do our next. X over R. What's X over R?
Oh, sorry.
What is it?
3 over 2.
There we go. Square root of 3 over 2. Okay, tangent, y over x. Square root of 3 over 3. Why is it square root of 3 over 3? Because we would have 1 over square root of 3. Is that allowed? No. So we rationalize it and we get square root of 3 over 3. Okay, now I just got to find their reciprocals, right? What is the reciprocal of 1/2? 2 over 1, which is just 2. What is the reciprocal of square root of 3 over 2?
See, I got 1, and I don't think that's 1.
So 2 over the square root of 3, but I have to rationalize, which gives me 2 square root of 3 over 3.
Yeah, for him.
Okay. Sure, we did last week on 6.3, but we're gonna keep going. Cotangent is reciprocal of 1 over square root of 3, which would just be square root of 3. All right. So is there gonna be a big difference between focusing on 60 at the origin?
No.
No, there is not.
I go upside down.
Exactly. They're not exactly the same, but they are very much similar. Okay. So we have 1, 2, square root of 3. So when I'm looking at the 60, 30, 90, I'm now just going the other way. This is now my X. This is now my Y, but everything else is going to be the same. Okay.
Did I draw my name?
Yes, you drew it upside down. Okay. The 90 should always be on the X axis. Oh, crud, guys, we didn't write our ordered pair.
What ordered pair?
For our 30. Ordered pair so that the radius could be a 1. Depends on your sine and your cosine. What's the cosine?
Square root of 3 over 2.
And what's my sine?
1/2.
So that means the ordered pair would be square root of 3 over 2 and 1/2.
What was the one for number 2?
Square root of 2 over 2. Square root of 2 over 2. Remember, it's the cosine and the sine. Okay. All right, here we go. 60. Really quick. Y over R. Y over R.
Square root of 3 over 2.
There we go. X over R.
1 over 2. Right?
Yes. Y over X.
2 over 1. So 2.
Y over X.
Oh, y over x?
Mm-hmm.
Sorry, it's square root of 3 over 1.
There we
So
go.
Square root of 3.
All right. And now what happens to the reciprocals? Reciprocate, right? So this one we've already reciprocated once. So it becomes 2 square root of 3 over 3. This becomes 2. And this becomes square root of 3 over 3.
How is it over 3?
Because it's 1 over the square root of 3. And when we have 1 over the square root of 3, what do you have to do?
Multiply.
Multiply by the root, the radical. We rationalize. We rationalize.
This is
You cannot rationalize with unrational.
People, people, unrationalized. All right, so we're going to talk about what's called cofunctions, okay? If you look here at 30, 60, 90s, do you see some similarities between their sine, cosine, tangent, cosecant, secant, and cotangent?
Is the ordered pair 1
Oh,
over
yes.
2?
We keep forgetting ordered pair, which is the whole purpose of this, guys. Oh, good job, good job. 1 over 2, square root of 3 over 2. Good job, guys. The rest of us are slipping.
What's the rest of us? I remember.
All right, so here we have cofunctions, okay? What makes two angles cofunctions is that their angles are complementary. Okay, do y'all remember what complementary angles mean?
Yes.
What does that
They
mean?
add up to make 180.
No, not 180, but
90.
90. Supplementary equal 180,
180.
complementary equal
90.
90. Just because they complement each other. Okay. 30 plus 60 is 90. So this is an example of co-function angles. Okay, a co-function relationship. If you look right here, the sine of 30 is going to be equal to the cosine of 60. Yes, do y'all see that? The cosine of 30 equals the sine of 60. Yeah?
Yeah.
Okay. The cosecant of 30 equals the secant of 60. The secant of 30 equals the cosecant of 60. And their tan and cotangents are opposites of each other. Yeah? So this is what we call a co-function relationship. And again, this happens when the angles do what? Equal 90. They're complementary. So if the angles equal 90. So for complementary angles, we're going to set just in general what would be equal to what. Okay. So based on what we have here, we know that the sine of one angle is going to equal the cosine of the other angle. Okay, I'm going to use the beta symbol for my other angle. It's just B with a long tail. Okay. Is that okay?
Oh. The German mother.
Yeah. So we're saying that theta plus beta equals 90. Okay. Just ignore her, y'all. Just ignore her. All right. So theta plus beta equals 90. Therefore, the sine of theta is going to equal the cosine of beta. Does it make sense? All right. And then we would have the tan. The tan of theta is going to equal the cotangent of beta. And in terms of reciprocal, we would have the cosecant of theta is going to equal the secant of beta. And this is going to be vice versa. If I write vice versa without writing all the other sixes, would that make sense to y'all? Okay, so vice versa, meaning that sine of beta equals cosine of theta. Does that make sense? Tan of beta equals cosine of theta. Yes? Are we okay? So again, if two angles are complementary, meaning that they equal 90, if I know one of their trig ratios, then I can find the other one also, right? Okay. All right. So let's talk about being able to ways to help us work on memorizing, working together. I'm going to show y'all some of the different ways. So the first thing here is some people, it helps for them to look at it in the form of a table. So they learn this table and then they put the table where it goes. Okay. So learning the table, if I'm looking for the sine of 30, the cosine of 30, the tan of 30, the sine of 30 is going to be my ordered pair. What's the ordered pair for 30? What do we write? And what about 45?
Square root of 2 over 2 and square root of 2 over 2.
And then what was?
1 half and then square root of 3 over 2.
Okay. All right. So when I'm trying to remember, I either can just focus on remember them as ordered pairs, or I can focus on the table. So the sine of 30 pi over 6, your sine is always your what variable? Your y. So in the sense here, it would be 1/2. Your cosine is always your x. Okay. Your tangent is a little trickier. But your tangent is also doable. It's just your y times the reciprocal of your x. And that's a way to think about it, or remembering it. The other thing is just remembering your triangle. If I'm in quadrant 1 and I have a 30, 60, 90, 1, 3, and 2. Can I find these just by using basic SOHCAHTOA?
Yes.
I can, right? I can simply say, okay, what is tan of 30? Tan of 30 means opposite over adjacent, which is 1 over square root of 3, which makes this square root of 3 over 3. Does that make sense? So there's all these different ways to help memorize. I can't tell you how to memorize. It is how do you memorize and digest information. I can show you all these things, but how you choose to memorize is 100% up to you. Okay. So here, 45. 45, the sine is gonna be square root of 2 over 2. The cosine is gonna be square root of 2 over 2. And x over y is just gonna be 1. And then you just keep going and filling it in, okay? So our plan for tomorrow is to practice filling in the whole circle. After we finish filling in the whole circle tomorrow, we're then gonna play bingo, okay? All right, on your assignment, I want you to try doing it with little a as possible.